Well, hello friends. Today we're going to work on the browser again, and I'm going to make a little DOM tree inspector or viewer or whatever, so that when we bring up a page like this, currently we have a way to dump the DOM, which will give like this text-based dump on the terminal here where we're running Serenity, but it would be really nice if we could see it in a tree view, so we can see the DOM, what it looks like. So let's make something like that, and I imagine that we would just pop it up in a second window in the browser. So let's see how we would do this. So I imagine that if you let's say, do we want to put this in a debug menu? Maybe we'll put it in an inspect menu. Wouldn't that be cool? Because debug is like, you wouldn't want this in the final version of this, or release version of this software maybe, but an inspect feature would be more, or no, what am I doing? Add action. An inspect feature could be more release-like. Inspect DOM tree, let's say. And we'll have a callback where we will, I don't know, create a window. Or we can say, we can do that here actually. Purge window DOM inspector window. And then we'll say if DOM inspector window. If we don't have one, then select. I'll just put it somewhere. I don't know, numbers. DOM inspector window. Move to front. Show. All right. So far so good. And then I guess we want to do something with this window. So I'll put something in there. I want a, let's say, a tree view. And tree view construct, and we'll just put, we'll just give it no parent, and we'll set it to be the main widget of the DOM inspector window. Okay, and I guess we can store this here actually. DOM tree view, just so we can access it. DOM tree view. Okay, and when we do inspect DOM tree, then we want to do like DOM tree view set model, I guess, and then we need the HTML widget document. We want to make a model for this, so let's construct one. Let's say DOM tree model construct with the document. If there is a document, so if there is a document, then we'll make one. Otherwise, we'll say DOM tree view set model null footer. Okay, now we just need to invent this fabulous DOM tree model. So I think I'm going to sketch it out here first. And let me go, and how do we do this? What's some existing thing? We have remote object graph model. That'll be a start. create document. Okay, so we can create a DOM tree model from a document, and we're going to hold on to that document. DOM tree model. I just wanted to copy this so I have something to start from. We don't need any icons. Maybe we will need icons eventually, but not right now. Maybe we can call these element icon and text icon. Because maybe we will have little node icons for those. I don't know. We'll see. And these are good. And I'm just going to put this into a separate file right away, actually. And let's put this in libhtml, because I imagine that, like, if you're using libhtml in another application, not the browser, it might still be very useful to be able to pop up a tree view of the DOM. So, where do we put this? I guess in the DOM. I mean, it's not a DOM implementation thing, so I don't know. It's not really logical. We're accumulating these like things here to where I'm not quite sure where to put them, but don't have to figure this out right now. The directories will make themselves obvious eventually. Okay, meta, and we'll just take this and put it in libhtml DOM tree model. Good model. Okay, so I think spelling is good. Okay, then remote object graph model. I'm just going to copy this as well. And DOM tree model. This is going to be very different from. By the way, the remote object graph model. Let me just show you what that is. So that's. Oh wait, hold on. What's the program? 13, the launcher. So right here, this is the object graph of the launcher program. So we can see that there's a window and it has a widget in it, and then it has all these buttons. Each one of these is a button. So I've worked on this in a video. It's an inspector that allows you to connect to a running application and inspect its various runtime objects. This is actually something that I would like to integrate in Hack Studio as well eventually. But right now I'm just stealing the code for this tree model here. So we are just going to do a search and replace first. Oops, DOM tree model. Very sophisticated programming happening here right now. And document and doc, and maybe we wanted to load some cool pictures here. Let's say graphics bitmap load from file. Wait, is that okay? No, that's probably not. Or, hold on. What did we call these? Element icon and text icon. Maybe that's okay. And we will use file type unknown for the text, maybe? I don't know. We'll see how that looks when we get there. So now we have to implement everything that turns all of this stuff into a tree. I mean, the DOM is already a tree, but we gotta like transform it into the DOM tree model way of things. So node, I guess. Let's see how we do this. the index for a row and column. So the column is easy, but the row is like the gmodel. The way the gmodel works for trees is that with tables it's easy, right? Because gmodel is just basically a row and column based model. But indexes or indices, they also have a parent index. And in a table model, then the parent index is always null, or like this, right? This gives you a regular table, flat table, with no hierarchy. But in a tree view, each index can have a parent index, and that's how we work out what the tree structure is. So that's what we have to do here. So when we produce an index, I guess we can do the what we want to do is we want to produce index objects that refer to the DOM node internally, and that's how we're gonna extract data from the DOM. So we'll do lib.html DOM node, and say we just need document maybe. And we can call this node, and if node is element, then we'll return the element icon. Node is text. Let's just always return the text icon for now. Fix me more node type icons. And then we want to do some kind of a name of the thing. So I guess we'll just do node tag name. If it's an element, then we'll do it like this. If node is text, then we can do the whole text, I guess. Node to text node. We need text. Text content, or what is it? Character data. Data. Yeah, data is the thing that we want. That's cool. Else, actually, if it's anything other than text, then we should just do the tag name. So we can do it that way. Okay. And the row count tells us for a given index, how many children does this index have? And if we are at the root level, then we need to know how many root level things does it have. But in our case, I guess the document is always the root, and the document does not have siblings. So at the top level, there's always one. And then we can cast to node. And does node have a child count? No, we have to compute the child count. Okay. Node for each first. No, we don't have this. We should probably, this is stupid. We should have a child count helper. Tree node. Let's just add this. So let's see, int child count. Child is child. Next sibling. Plus count, return count. All right. That makes more sense. And then let's do parent index is the most annoying one. So let's do this one first. So if we don't have a parent, that means that we are at the top level, which means that we want to create an index for the document. And that means that we just pass mDocument as the node object to the index, as the internal data object in this index. Because indices have internal data. Maybe I didn't mention that. So every index is a row, a column, and then, of course, also the model. It's a model, the row, the column, and then an internal data that you can do whatever you want with. And that's how we are able to do things like have an index that represents not just a place in the tree, but also like has a pointer to the DOM node, or whatever else a data structure you have underneath. But I'm not so used to working with this stuff, so I'm a little bit shaky with it, but I think we can work this out. So let's say node is, this is the parent, so this would be the parent node. And we want to find that the parent has a child with a certain index. Parent node child at index. Is that the row? Yeah. So maybe child at, we'll just make a helper for this as well. So const t child at index. And it's kind of the same as this thing, I guess, except that if count is index, return child. Otherwise, return null footer. All right. So we can make a const t version of that. I'm starting to accept that I'm just going to do this to implement const versions of things whenever possible. Gina is child at index. Instead of duplicating this code, I'm just going to use constcast. And what are we doing here? We cannot take the address of an R value of type node. Wait, child at index. Oh, right, yeah. We don't want to take the address of it, it's already a pointer. And then finally, to compute the parent index of something. If we are at the top level, if the index is not valid, then the parent index is also not valid, right? But here, node, if node has no parent, then the parent index, it's presumably the document, right? Which means that the parent index is empty. And if the parent has no parent, it is a root. If the parent has no parent, what the hell does that mean in this case? If our parent has no parent. Okay, I'm confused by that, so let me just move on because I forget how this works. And then we want to iterate through all of the children here and figure out what is it that we want to do. We want to create a parent index for an index. And the parent index for an index is just an index. The tricky part is computing the row number of a parent index, because the row number is the index of the parent node, in this case, in the grandparent's child list. So let's see, int grandparent sibling count is node parent. Oh, I see why they were checking parent if there was no grandparent. If there is no grandparent, that means that our parent is the document. So we can just return parent is the document. Create index 0, 0, document. I think that makes sense. And otherwise, we walk the grandparents' grandchildren. So parent sibling count is the grandparent child count. Maybe grandparent child count is a better name of that node. Parent child count. Actually, no, we just want to iterate through the grandparents' children and figure out what is the index of the parent, right? So for auto, node parent first child, grandparent child. Grandparent child is grandparent child next sibling. Okay, and then we, oh, that's a bit messy, or not messy, but long. Grandparent child index 0. If grandparent child index is the index row that we are looking for, no, that's not what we're looking at. We want to know if this is our, if the grandparent child is our parent. So if grandparent child is node parent, then return create index grandparent child index column 0 node parent. Okay. So walk the grandparents' children to find the index of node's parent in its parent. Needed to produce the row model index corresponding to node's parent. DOM tree model, we cannot construct DOM tree model, right? But we can do this. Wait, where's DOM tree model? Oh, there's DOM tree model create. My bad. All right. And we have to star that. Okay. Let's see how this works out. And I forgot to add the inspect menu to the menu bar. Menu bar, add menu, move inspect menu. Bloop. Okay. And what do we have in here? A doc type node, HTML. How cool is that? This is basically the DOM tree. You can see all these empty text nodes here, looking all useless, but that's how the DOM looks. So this is pretty cool. Oh, look at all this crap. What the heck? Oh shit. Yeah, because it has new lines in it. Oh. Yeah, if you have new lines in text that you try to print out. I wonder where we're screwing that up. Oh, it's a style sheet. It has a bunch of new lines in it. Yeah. We don't tolerate that very well. We should figure out a way to deal with that. Maybe in the DOM tree model, we can collapse white space into single space, maybe. That would be one thing. I mean, obviously it would be better if we could make the text node like tall enough that it could show everything that's in it, but currently TreeView does not support different height nodes, so that's very it's non-trivial to do, and it's far outside the scope of this video, so I'm not going to work on that now, but we can do something to make the text not render so fugly. That would be where we extract here, where we extract this text from a text node. We could collapse the white space. So do we have some function for that? I guess we don't really. We can just do it here then. Static string collapsed with white space collapsed. We'll use a string builder for this. And what do we say here? While string I if is space, I guess. We need C type. If it's space, and while, and then we'll add a space to the builder, and then while is space string I, while I is less than string length, and it's space, then we'll plus I, continue, otherwise we'll just builder append string I. It's not fancy, but this will do the trick of collapsing it with white space collapsed. Okay. The way these work is a little clumsy. Maybe that we should open. Is it double click to open or close or what? I feel like we should open the whole DOM immediately. This is not perfect. SS comment. I feel like we're skipping over something here. When we are collapsing, then we reach something that's not a space. Then we definitely want to add that. So if is space otherwise builder append string I continue. I'm gonna break. Okay. Plop. All right, come on, bro. Let's see that style sheet. And looking pretty reasonable suddenly. Yeah. Lol, a CSS comment. Wow, some profound stuff going on here. This is really neat. So let's give the DOM inspector window a title, because I didn't like that it was so ugly titled. Set title DOM inspector, maybe. And we could do something fun here. Like if you select something, we could paint it differently. Let's try that. That would be kind of fun. So I guess first thing we can just commit this. DOM tree model. Or wait. Yeah, let's just do this in one go, actually. Browser, add a simple DOM inspector pop-up. HTML now provides a DOM tree model, which can be used to view a specific given document's DOM tree. Cool. Okay, so let's do something fun. We'll say that DOM tree view on selection. We will. What exactly do we want to do here? DOM inspector window. Not the window. Oh, actually, we have the index that we're selecting, I think. Or do we? On selection. Yeah, we get the index that we're selecting. But the thing we really want to hook is on selection change, I think. On selection. No, on selection is fine. We should probably use on selection. Because we're interested in when you're selecting a specific index. So on selection, auto index, and we'll do index.internal data static cast node. And here we will say that node or document node document set inspected node is node. That's pretty cool. And then we will have a thing in document because we already have the hovered node, so we could have the inspected node as well. And we'll have a way to retrieve it. Which will just be return an inspected node. And that should not be const. I think just like the hovered node, where's the hovered node? Let's have inspected node also keep the node alive so that if for some reason the node is removed from the document while it's being inspected, then we don't have to deal with that scenario in the inspector logic, but it can just retain it even though it will be detached from the tree and become parentless, but that's still okay, I think. Although, yeah, because we just have to be careful about null checking the parent everywhere. And when we set the inspected node, we will first, if m inspected node is node, then do nothing. Otherwise, m inspected node is node. And when this happens, I guess we will just say, how do we make it repaint itself? Frame set needs display. How do we get the whole thing to repaint? I forget. Update. I mean, I guess we can, I don't want to do a style update because this isn't style related, this is just painting. So if m inspected node, layout node, if m inspected node and then layout node set needs display. That's how we repaint it. Yes. Okay, and then when we paint a layout box, here's the background color stuff. So I'm thinking that we could do something cool where we just draw a if node and document inspected node is node, then rendering context painter draw rect my rectangle in a cool magenta. Why not magenta? Let's see how this goes. So this it's not going to do anything for text nodes, only for things that have CSS boxes, or I mean, that have like block level boxes, basically. Inspect the DOM tree. These things are not visible. Wait, nothing happens. I thought something would happen. Okay, this is not, oh, and there we die because we didn't realize that we changed the page. We definitely need to, let's see, DOM tree model. DOM tree model should probably hold on to the document, yeah. Let's do it this way, and actually, in fact, we'll do it that way, so that you have to have a document. I think that's better. Then it will keep working, and having the inspector will actually keep the the document alive, even if you navigate away from it. This is something that actually bothered me a lot when using Safari or Chrome or Firefox, that like you navigate away from a page and the inspector loses state. Like, I wish I could keep the page. Now things go wrong in a different way. What happened now? DOM tree model row count. What am I doing wrong? Tree view, update content, set model. DOM tree model row count. I don't know why that would not work. What did I screw up now? End document is a non-null ref footer to document. Why would that be a problem? What? It's uninitialized malloc memory. Okay, sure. So I guess in row count we are calling child count on an invalid thing. And what did I change exactly? Set model. Set model, where are you? Here. Update content size. Presumably that's where we end up here, right? So that stack frame is collapsed. At this point, we've already taken ownership of the new model. Update content size. What the hell is this? So lambda and update content size. So in this lambda here, we're doing something that's no in row count. I guess traverse and paint order is getting the row count for the index. Why is that a problem? And it all changed because of this. DOM tree model. If I just use a raw reference, then this doesn't happen. Is that really true? Okay. Now, why is that? I wonder. New DOM tree model. And at this point, we ref the document. And what is this? Why does this anything turn out different because of this? Oh shit. Oh, so stupid. Okay. Because we're taking the address of mdocument. Okay. Yeah. Because because this is passing the internal data for the index, so it's a void star, so it can take anything. So you got to be careful that you're passing the right thing. You can't be passing the address of a smart pointer. Okay. But I would have expected this to show some magenta boxes. Let's go in test page here. I'm clearly selecting these things, but it doesn't. Maybe we're not setting the inspected node. Set inspected node. Node, and let's look in layout box and see. Okay, this selection is not reacting. Okay. So, DOM tree view on selection. You don't care about me? Okay. DOM tree view on selection index. We'll just do that. Oh, maybe we should also include the. Wait, when we output an index, does that include the internal pointer? It doesn't. Well, it probably should. So let's make that do that. If value internal data. Else we'll do this format. So here we'll put oh. Okay, does on selection not actually happen in tree views? I'm confused. On selection, who does these? Tree view does. And you call did update selection. Which happens in notify selection changed, which is called by the selection when we set a selection. This is very surprising to me. Why does this not stick? I'm going to try this one more time here. On selection change. See if we get this call then. Maybe we're not getting the on selection callback for some reason. I knew how this worked recently, but I forgot. On selection change is happening, but not on selection. Okay. On selection change. Why are you being triggered? Who fires you? Notify selection changed. Did update selection. Presumably calls this one. Oh, but this one does not call it. It doesn't call the parent class. So abstract view did update selection takes care of this. So we're forgetting to call the base class in gtree view update selection. And what does the base class do? Stops editing if we're editing a currently selected thing, and then it calls on selection if it's registered. And table view doesn't have did update selection. That's why it doesn't matter there. So I guess we can just did update selection. I guess we can just do it here at the end. G abstract view did update selection. We'll do it first of all. Be good boys. Let the base class do what the base class wants. Sometimes I wish C++ would let you say that if you have a base class something, then on this thing I would like have something like required or must be called or whatever. I don't know what you would call it, but something that says that anyone who overrides this virtual has to call the base class virtual, because it's very easy to introduce kind of subtle issues if you break these semantics that you set up for yourself by having base class virtuals that are expected to be called, because it's easy to forget to call them and no one's going to tell you. I think that would be a good improvement to the language, actually. So maybe I just rebuilt twice. I don't know. Anyway, so we're only getting on selection change still. Oh, because I didn't rebuild libgui. That's my bad. Let's do a full build since we're changing gtree view. I'm trying a different lamp, by the way. I hope it's working out okay. People keep telling me I look like a corpse in these videos. So many people have told me, and I have a few different lamps, so I guess I can try them all. This one is distinctly yellower, as I'm sure you've noticed by now. Oh, look at that! Boom, 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 boom. And we're gonna need to remove the previously painted thing, but let's see. Document. So we'll repaint the outgoing inspected node. Yeah, I got that in magenta. That's pretty cool. And let's also do this for text nodes. So when we render a text node fragment, we call render fragment on layout text, and here we could be a little cheeky and say document magenta if documents inspected node is my node, then we will fill, or not fill, but we will draw the fragment rect in magenta. And closing interact left the fragment rect in magenta. I don't know how this will turn out, we'll see. So if we bring this guy up, so these things, you can't see them because they're nowhere. But here, now we can select, see, we can select the individual text nodes. It's pretty cool. So let's bring up this other page, close that one, get a new inspector, and go here in the body tag. So we have this. Now we see all the different text fragments. They get like a little purple around them. And there we died. Why did we die? It's some IPC problem in the Windows server. Oh, I wonder what that is. Maybe we're sending an obscene number of rectangles or something. Let's see if that reproduces. Lorem ipsum. It's fine, it's fine. Probably was just some temporary bug in the IPC there. That's so cool. I love it. We should have a different icon for this one, the document node. DOM tree model. I want to give it a special icon. This document. No, not you. You. Document icon, and it's going to be set bitmap for size, blah blah blah. We'll grab the file type HTML. Get rid of all of this spam here. I think this could be really cute. Look at that little icon. Adorable. Of course, there's so much more that can be done with this, but I think we've already built something pretty interesting here. We could tell you more about the individual node, show you the different style that applies to it, and so on. Yeah. We can think of things, but I already really like this. So neat. So let's commit what we have. Starting with gmodel index, which I think was just changing the log stream stuff. Yeah. Commit with GUI include internal data in gmodel index log stream output. If a gmodel index has some internal data set, now include that in the, okay, super redundant. And then tree view, we changed it to call the base class in did update selection. Let GUI make g tree view fire on selection hook. G tree view was forgetting to call to base class in g in did update selection. Call to base and did update selection. This prevented abstract view from firing the on selection hook, and we did with only the on selection changed hook. hook firing. Okay, and then in the DOM tree model, we added the icon for the document. And also store the document in a smart pointer. Add document icon and DOM tree model and keep document alive. Finally, we store the inspected node on the document and draw it with a little purple rectangle. HTML. Draw the currently inspected node with a, say, paint actually, magenta rectangle. Paint a magenta rectangle. Rectangle. On the currently inspected node. Document now tracks one inspected node set from calling set inspected node. Just call it by the DOM inspector view. DOM inspector view selection callback. This is not perfect, but it's okay. I think we're probably going to want to take the inspector functionality out of the browser main file and bundle it into something so that you can get this this set inspected node. We want that to be available to anyone who wants to embed an inspector. But right now this is okay, but then we can factor it out into a more embeddable component. But I think that's cool. So this is, oh, this one does not have a rectangle. Interesting. So I think this is going to be it for today's video. So if you made it this far, then I thank you for watching. And I hope you saw something interesting. And I will see you next time.